talking about what if the value of n that I'm taking, if it is less than 1 or it is in the negative terms. So like they have said here, binomial theorem for any other index where x modulus x is less than equal to 1. Now you have to remember this thing. For any other index where generally we consider n to be minus 1, generally this is our general case. For this we can open this entire equation 1 plus x whole to the power n in this manner. Now I hope you all can see that 1 here is nothing but nc0, n here is nc1, this value here is nc2, because I've opened up n twice and divided it by 2 factorial. This is nothing but my nc3, and similarly this is my ncr, and this goes up till infinity. Now I can still find out the value of this entire equation even if it goes up till infinity, because x here is less than 1. Modulus x less than 1 means x is less than 1 and it is greater than minus 1. This is what I'm referring to here. If x is less than 1, that means at infinity the value of x is going to be so small that the entire term would become 0. So let's say if my x is less than 1 and greater than minus 1, and here I'm saying what is going to be the value of x to the power infinity here. Now x is so small that its power to the infinity is going to be of course 0. So this would become 0, because I hope you all know that if I have a number which is less than 1 and if I keep on let's say multiplying the number with itself, if I keep let's say increasing the power of that number, what is going to happen? The value of that number is going to decrease. Let's say if I have 1 by 2, what if I say 1 by 2 whole square? It is going to be 1 by 4, which is of course less than 1 by 2. And then what if I say if I take it to the power 3, it is going to become 1 by 8, and 1 by 8 is less than 1 by 4. So I hope you're understanding, as I increase the power of a number which is less than 1, it is going to turn out to be 0 sometime when my power becomes infinity. So similarly, for such type of cases, of course, you can directly find out the value of such equations. And reminding you of one more thing, this type of equation we will be learning in more detail when we are studying limit, continuity and derivability. So right now, for the time being, just to solve questions of binomial theorem, it is necessary that you remember this formula and solve questions based on this. Now you have to use this type of opening or expansion only when n is, let's say, negative and x is modulus x is less than 1. So you must remember this thing. Now we will look at a few general openings that you must remember. Now this one is a very important, and these two are really very important for you to remember. Of course, this one is not much important, neither is this one. However, you can still have a look at it, how they've done the calculation. 1 plus x to the power minus 1. Now what did we study just now? 1 plus the expansion of 1 plus x to the power n. How can we open it up? 1 plus nx plus n into n minus 1 upon 2 factorial x square plus n into n minus 1 into n minus 2 upon 3 factorial x cube, and this goes up till infinity. So that is what exactly has been done here. N is our minus 1. So if I put it here, it would become minus x plus x square, and this goes on up till infinity. And instead of, let's say, 1 plus x, I have 1 minus x, then each and every term would become positive, because of course the places that I'm getting the negative sign here are all the odd terms of x and odd terms of x. Since x here is, we are considering this to be 1 plus minus x to the power minus 1. So all my odd terms of x are going to be negative as well. So they are going to turn into positive. So these two are special cases that you must remember. Apart from this, again, this formula is something that we are going to study in much detail when we study limits, continuity and derivability. This is just for your understanding here right now. Now let's talk about finding out the greatest term in our entire binomial expansion. Now let's say if you have a plus b to the power n, of course you are going to open it up as nc0 a to the power n plus nc1 a to the power n minus 1 b plus, and this goes up till ncn minus 1 a to the power 1 b to the power n minus 1 plus ncn b to the power n. This is how you are going to open it up. Now depending on the values of b and a, of course you can find out which is going to be the greatest term in this entire equation. So there is a formula of finding it out. What do? We is we find out the rth term, we find out the r minus 1th term basically. Once we've done that, what we do is we try to find out its ratio. And upon simplifying this entire ratio, what do we get? B by A n minus r plus 1 upon r. Now what is our task here is we try to equate it to a, let's say, a value 1, so that we get r in such a way. Let's say if I get my r value upon solving this entire equation, what I'm saying here is I'm keeping b by a into n minus r plus 1 upon r, this value to 1. Now of course b by a is going to be something, n minus r plus 1 by r is going to be something, this value I'm equating it to 1. So from here I can either get, I am going to solve it for r. So I'm going to either get my r belongs to, let's say, integers. My r is either going to belong to an integer category, or r is not going to belong to an integer category. So if it belongs to an integer category, so simply r equals to r, that becomes my answer. If it is not an integer, then what I'm going to say, my r is going to be bracketed x, that is, this is my greatest integer function. I hope you all remember GIF. This is my greatest integer function. What do I mean by greatest integer function? Let's say if I have a greatest integer function of 5.76, so this value becomes 5. If I have this under a square bracket, then I say that my greatest integer function is 5. If I have 5.3, this becomes 5. So there is no rounding off here or anything. It is simply just the greatest integer that I can see inside the box, that becomes my answer. So if r is not equal to an integer, then my greatest integer of r becomes my answer. But the thing is that I have to approximate this ratio somehow to 1. And at r is equals to whatever value we get, at that value, if I find out the term that I'm trying to find out, that would become my answer. So from here, my as it has been mentioned here, solving the equation tr plus 1 upon tr is equals to 1 gives an approximate value of r. Of course, if I'm getting directly an integer, so there's no problem with that. If I'm getting an approximate value of r, I simply have to take the greatest term, and based on that, what I can do is check integer values around r. After finding the approximate value of r, check the integer values around it to determine which term is actually the greatest. Now once I've determined what my r is, if I find out my rth term or r plus 1th term, I simply have to find out this term and this term. Out of these two terms, one of my terms is going to be my greatest term. So this is how we find out the greatest term in this entire equation. Now talking about greatest coefficient. Greatest coefficient is nothing. It is very simple. Simply my middle term. Now by greatest coefficient, now you must understand that greatest term and greatest coefficient are completely different. When let's say if I have r is equals to 0 up till n, and here I have ncr x to the power n minus r y to the power r. Let's say I have this expansion x plus y to the power n. Now when I talk about greatest terms means this entire thing is my term. However, just the constant part without the inclusion of x and y, this part is my coefficient. So by greatest coefficient, I mean I'm talking about only the NCR part. So of course we know that in the middle term, my coefficient is going to be greatest. So I simply find out the middle term, and at the middle term, my coefficient is going to be greatest. Now let's say if I have n is equals to even, then I would have my greatest coefficient at n by 2 plus 1th term. And let's say if my n is odd, my greatest coefficient is going to be at n plus 1 by 2th term and n plus 3 by 2th term. So this is how greatest coefficient is found out. I hope you must have understood how the difference between term and coefficient. So term includes an entire portion, and coefficient is just the constant part that we are dealing with, without including of course the a and b or x and y, whatever is there inside the expansion box. So that was all about the theory portion of this chapter. Again, repeating things again, JEE does not directly ask questions from this chapter, because again it may ask of course, but it is very rare that you see a direct question from this chapter. However, in each and every paper you will see that the concepts of this chapter have been used in some other question, and they've mixed the two chapters and then they've asked the question. Of course, direct questions are very rare. However, there are a few. We will look up to that in our next lecture. And so that is all about this chapter. let's look at our previous year questions now.